Hi, now we are done with the string methods. So today we'll see complex data type. Complex numbers are written in the form a plus bj, where a is the real part and b is the imaginary part. And j is equal to the square root of -1. We cannot write the notation like a plus bk. This will be invalid. We can only use j for representing imaginary part. So now let's see some examples. Creating a new folder inside Python 6 complex and a new file a.py. We will create a variable c equal to 3 plus 7j. Firstly, we'll see what is the type of this variable. So print type of c. Remember the type function, okay, and running a.py. See, complex is a class in Python, okay. Every data type in Python is handled by its class, okay. New example b.py. Now what if our real part is 0? If we only have imaginary part, then we can write like x equal to 4j. So let's see if this is valid or not. Print x, and let's print the type of x also. Print type of x, okay. Now running b.py. Okay, so this is a valid complex type, okay. So we have seen that we can only use j to represent imaginary part. Let's check if that's true or not. New example c.py. Let x is equal to 3 plus 4k, and we will run this. If this statement is not valid, then we will get error in declaration itself, okay. We don't need to write here print statement. So running c.py. Okay, so see, we are getting error, invalid syntax. Means we can't use any other representation other than j, okay. Now let's see the new example d.py. Now we are using the integer data types for the real and imaginary part. Let's see if we can use float or not. So a equal to 4.9 plus 2j, let's say, and b is equal to 8 plus 2.7j, and print a and print b. Now let's run. Okay, we are getting the values of a and b. That means our real and complex both parts can be of floating point type, okay. Now in integer data types, we have seen different types of integers. These are binary, octal and hexadecimal. So let's see we can use them as the real and imaginary part or not. First we will see for real part. Let's make a new example e.py. Let a equal to 0p101 plus 2j and print a. So let's run. Okay, so the binary integer is converted into its decimal form, so it is valid, okay. Now I'll comment this, and x is equal to 0027 plus 3j. This is octal representation, okay. So let's run. Okay, the decimal corresponding to octal 27 is 23. It is valid, okay. Now let's see for hexadecimal. Comment this. X is equal to 0x7a plus 5j. Let's run e.py. Okay, 7a in hexadecimal is 122 in decimal, okay. So we can write the real part in the form of binary, octal and hexadecimal integers. Okay. Now let's see the same for imaginary part. We'll see this in new example. New example f.pi x is equal to 3 plus 0b 11j. Okay. And print x. Oh, see, this is not valid. We can't write the imaginary part in the binary decimal. Okay, and maybe the case is same for octal and hexadecimal also. Let's check. Comment this. X equal to 3 plus 0o27j. We only need to check that these are valid or not, so we don't need print function here. So let's remove the unnecessary code and let's run this example f.pi. This is also not valid. Okay, now let's check for hexadecimal also. X equal to 3 plus 0x7a j, and running f.pi, invalid. Okay, so in a nutshell, we cannot write the imaginary part in the form of binary, octal or hexadecimal integers. Okay, now there are two properties of complex class. These are real and imag. The real part of a complex number can be returned by a real property and the imaginary part can be returned by imag property. Notice this is not imaginary, this is just imag. Okay, and I'm not saying these two as functions or methods because we call functions by using parentheses and we cannot use parentheses with these. Okay, so these are not functions or methods, these are the properties of complex class. Okay, so let's see. G.pi will make a complex number c equal to 3 plus 2j and we will print these properties. Print c.real and print c.imag. Now let's run. Notice the outputs. Okay, we have not given the numbers in floating point types, so why we are getting these results? This is because the real and imaginary parts are stored in the form of floating point type. Okay, so that's it for today. If you have any doubts, then feel free to ask them in the comment section. And see you all in the next lecture. Bye bye.